Today we're reviewing for Chapter 3 test. This is for Algebra. So we're going to start by looking at a word problem. It says tickets for a school play cost $7 for students and $10 for adults. They've given us the equation that represents that. So the number of students X and the adults are Y who can attend the play, and they can attend for $80. So if no students attend, how many adults can see the play for $80? So that would mean 0 would need to go in for X, which represents students. So we have 7X plus 10Y equals 80. We're going to plug in 0 for X. So we get 10Y equals 80, and we divide both sides by 10 to get Y by itself. So Y would be 8, or 8 adults can go to the play. Next, we're solving for A. It gives us the point A, comma, -8, and -8 represents B in the equation. So we have -A equals 4 times -8, and we're going to solve for A. So we have -A equals -32 minus 7, which is -39. Since we can't have a negative variable, I need to divide that by -1 to cancel the negative sign out, which makes it positive 39 for A. Here we need to find the x-intercept. That means we plug in 0 for Y. And solve. So we have 3x equals 7, divide by 3, and we can just leave our answer as a fraction. So the x-intercept would be 7/3. Next, we're supposed to solve this by graphing. So we first need to get it into slope-intercept form, where we have everything on one side equaling to 0. So we're going to add the 3. We have 0 equals -2x plus 2. The 0 represents y, so this is our equation that we're graphing. You could graph this several ways. You could graph this using the y-intercept as your starting point, which would be 2, or 0, 2, and then your slope to continue, which would mean to go down 2 to the right 1, down 2 to the right 1, and so on. Or you can make a table, or you could find the x and y intercepts. As long as you use one of those methods, you should have a graph that is correct, and the graph should have at least 2 points. So I'm going to just use the y-intercept and the x-intercept method. So that means I'm solving, let's say, for my x-intercept. So I'm plugging in y as 0. And I need to get x by itself, so x would be 1. So one of my points needs to be 1, 0. Then my other point needs to be for the y-intercept. So 0 is going to go in for x, which gives me 0 plus 2, or 2. So my y-intercept is 0, 2. So I'm going to plot 0, 2, and 1, 0. Oops. So 0, 2 is going to be up 2 spots, and then 1, 0 is going to be here. So that would be my other point, and then I would draw my line through those 2 points. Next, we're going to graph this equation, and again we want to put it equal to 0. So we subtract 3, And this is the equation we're going to use to get our intercepts so that we can graph. So our x-intercept is going to be when we solve for x, so we have to multiply by the reciprocal. And we get -1 for x. So our ordered pair is -1, 0. And then we're going to solve for our y-intercept. And that's -1/2. So that point will be 0, -1/2. Excuse me. So now we're going to graph these 2 points. We probably want to do our scale on our y-axis by halves since we have a fraction. Our x-intercept is going to go at -1, 0, which is here. And our y-intercept is going to go at 0, -1/2. So we're going to go by halves. And that would be our second point, and then we graph our equation. Now we're asked to find the root, which basically means solve, so we're just going to solve for x. And x would be 8, which would be our root. Now we're asked to find the slope. If it's undefined, which means a number over 0, then it would be written as undefined. So finding slope, you need to subtract the y-coordinates over the x-coordinates. And we get -3 over 8. And we can keep it as a fraction. Next, subtract our y-coordinates over our x-coordinates. We get 9 over 0, and we just talked about that. That would be undefined. And then one more. Gives us 3 over -5. Next, it's asking us here to find the rate of change, which is the same as slope, so we're looking for 2 ordered pairs. We start with 1995, 57.5%, and then we have 2009 is our next year, and it says that's 52.8%. And this is talking about people that have graduated with 4 or fewer years of study. So we're going to put those as our ordered pairs in order to find the rate of change. I know that my years are my x-coordinates, which are my independent coordinates, because time is always going to be independent. So we have 1995, 57.5. And then we have 2009, 52.8. We're going to subtract our y's minus our x's. I'm sorry, y's minus our y's over our x minus our x's. And then since we don't usually see a fraction with a decimal in it, we're going to just simplify this to be a decimal. So we're going to divide 4.7 divided by negative 14, which is going to give me about negative 0.3. And that would be my answer. And if I wrote it as a percent, it would be about 30%. Next, we're asked to find how long it will take the snail to travel 50 inches. It says it already travels 200 inches in 2 hours. We know that our time is always our x, so we're going to write our rate as our y over our x, so 200 over 2. And then we can actually set this up as a proportion, so we don't know how long it will be, so that's x over 50. Whoops, we need to switch that, because it's y over x. So we have 50 over x, and then we can cross multiply it to get 200x equals 100. Which gives us simplified 1/2, and if we think about what that means in terms of hours, we have a half hour or 30 minutes. Next, we need to determine whether the equation is linear, and then if it is, write it in standard form. So we need to look at these with two criteria in mind. One would be if you have variables directly next to each other, which neither one of them do. The other would be if either variable has an exponent other than 1, which also neither of them do. But for the first one, we also cannot have, in standard form, we can't have fractions. So we're going to try to simplify this, and if we can't simplify it to make it standard form, then that would also mean that it's not linear. We know the second one we can. Standard form basically is just the x and the y terms on the same side and everything else on the other side of the equal sign. So if we're trying to put the x and y terms together here, we would either need to bring the y over to be with the x or the x to be with the y. So I'm going to bring the y over, and that gives me 4x minus 2y, and since I have nothing left on the other side, I need to just write that as equal to 0. And that would be all I'd need to do here for standard form, since this is a linear equation. Now the top equation I need to multiply by 2 over 3 as a reciprocal, because I need to cancel out the fraction so that we don't have a fraction anymore. So I get 3 over 2x plus 3 over 2y equals 1. So that cancels out one fraction. Now if I'm going to try and cancel out these fractions by multiplying by 2 over 3, the reciprocal of 3 over 2 on both sides, what I'm going to notice is that now I turn my fraction that I changed to a whole number back into a fraction. So there's no way to simplify this without having fractions. So this would also be not a linear equation. Next, we're asked to graph the equation. So we want our graph to be in slope-intercept form so that we can find our order pairs. So we're going to put this in slope-intercept form. We need to take the x away because we don't want that to be with the y. We want y by itself. And then take the 3 away. Again, we're trying to get y by itself. And then I divide everything by 4 so that I have y by itself. And then I have negative 1/4 x plus 3/4. And the easiest way to graph the equation, I think, besides using slope and y-intercept at this point, is using the y-intercept as your starting point, and then also finding your x-intercept as your other point. So we know our y-intercept is our b value, which is 3/4, so our point there is 0 3/4. Then we need to find our x-intercept by plugging in 0 for y. So I'm going to get x by itself. I need to subtract by 3/4. And then I need to multiply by the reciprocal. That's going to be 12/4, which works out to be 3. So my x-intercept is going to be 3, 0. And I'm just going to plot those 2 points. And again, I'm going to probably want to go by a fraction for the y-intercept or the y-scale. So I'm going to go up by fourths. So my first point would be 0 3/4 right there, and then I can just go by ones for my x's. So my second ordered pair is 3, 0, and then I would draw my line. I'm also going to graph this. This is a direct variation equation, which means our y-intercept means we start at 0. So we're going to put a point at 0. And then this is already in the correct form, y equals kx. So the k is our slope. That means we go up 2 to the right 3. And put another point. And we would continue to do that to make a line. But we can make a line with 2 points, so that would be enough. Now we're looking at arithmetic sequences, so we need to determine whether this is an arithmetic sequence. It needs to have a common pattern. So if we go from 7 to 11, that's +4, 11 to 15, also +4, 15 to 19, also +4. So it does have a common pattern or a common difference, which is going to be 4. And then it is arithmetic sequence because of the common pattern. Next, we're finding the next 3 terms of the arithmetic sequence, so we need to find the pattern. To get from -25 to -22, you're going to add 3, and again add 3, and add 3. So the next 3 terms, I'm adding 3 to -16, which is -13, 3 to -13, which is -10, and 3 to -10, which is -7. So these are my next 3 terms. Here we need to write an equation for the nth term of the sequence. So the equation we use here for sequences is this. We're going to leave n as n and then plug in everything else and simplify. So the sequence starts with the number 3. That's going to go in for a sub 1. Then we have plus n minus 1 stays there. And the d is the common difference. So from 3 to 12, that's adding 9, 12 to 21, adding 9. So it looks like the pattern is adding 9, so that's going to be a 9. To simplify this, though, we need to distribute the 9. So we get 3 plus 9n minus 9. And then combine like terms, so 3 minus 9. That's negative 6. So our answer would be 9n minus 6, or plus negative 6. And now we're going to graph this, I believe, and make an equation. Actually, maybe just an equation. But this is a table that shows the amount of gasoline the car consumes for different distances driven. So we need to figure out which is our independent and our dependent variable. Distance is going to depend on how much gasoline we have, or how much the car is consuming. So that means distance is going to be, gasoline is going to depend on how far we're going. So the amount of gasoline the car is consuming, is going to be dependent. So that makes it y. And that makes distance x. So we need to write an equation in function notation. If they don't tell us what form, we always use the slope-intercept form. So to find the slope-intercept form equation, we need to find the slope first. Let's pick 2 points. We could just pick the first 2. So we have 1.05 and 2.10. So finding the slope, subtract the y's over the x's. So that simplifies to positive 0.5, and that's going to go in for m. And then to find our b value, we plug in one of the points, our y value for y, and our x value for x. We need to get b by itself. So that would mean we need to subtract 0.05 minus 0.5. Which gives us negative 0.45. And that's our b value. So our equation would be y equals 0.5x minus 0.45. And function notation would just mean to replace the y with f of x. So this would be our equation. And then how many gallons will the car consume after driving for 140 miles? The miles, remember, was the x, so we're going to plug in 140 into our equation. Which gives us 69.55. And that concludes our Chapter 3 test review.